To start off with, I'll just do a couple of quick introductions. Brandon, you mind if I do your introduction for you?
Please do.
All right. Just because we want to get through death by PowerPoint quickly. My name is Ned Nichtel. I am the CEO here at CodeLogic. A lot of time in the industry. My background is in low-level coding, lots of painful things. So trying to cure pain when it comes to stuff that we tend to heap on ourselves in this industry is big on my plate. Brandon, your background is not that dissimilar to mine. You have background in cybersecurity, transpilers, all sorts of interesting things. As a company, we're based out of California. We're a distributed virtual company, and we have people all over the world, here in the U.S., India, etc. So with that, I'll just quickly introduce what we are as a company, what we and what we build. From a top level standpoint, when we think about the problem domain that we're solving, it's essentially the butterfly effect when it affects systems, architecture, and code. You make small changes over here, it has this tendency to proliferate and impact things 2, 3, 4 degrees separated. If you think about it sort of from a graph standpoint, you end up having these things get impacted, nodes and edges and nodes removed from where they started. In practical terms, this leads to a lot of issues. And it actually, interestingly enough, starts with issues around planning. Can you effectively plan around big things like major refactoring efforts, swapping out libraries, addressing major re-architecture, all the way down to sprint level planning problems, wherein what is the actual scope of this ticket? How many impacted systems are there really going to be? A lot of that is guessing today, and a lot of that it tends to be removed from the person creating the pain up until which time that the problem's detected. This leads to a lot of disorder and entropy in the systems that we have today. You tend to have these code bases. They start off pristine, maybe you have a very nice architecture, et cetera, but they turn into what I like to refer to as a ball of mud fairly quickly. And once that happens, you start having a hard time understanding what's been impacted, who's been impacted, what changed. And this in turn becomes cyclical, wherein, again, you come back around to not being able to plan effectively, start taking shortcuts on addressing things that introduces order and disorder and entropy, and around you go in a vicious circle until you have a big mess. So our solution to this is what we call a software intelligence platform, and building one that is attempting to be as comprehensive as possible in terms of how we address understanding, mapping, detecting dependencies and relationships. And again, a key thing there, it's more than just dependencies. It's understanding the relationships between systems and how those things form up dependencies. So being able to, for example, look at the data layer and look at databases, and as well as doing static and runtime inspection, all the way through to stored procedure decomposition, for example, both code side and server side. And then enabling reporting and extensibility of the system through APIs to inform other systems and workflows. So just really quickly, a history on how we came to be big consumers, though, of Neo4j as a core underpinning of what we've built. We started with a relational database, and that turned out to be quite a large mistake, led to a huge mess of satellite tables. We tried doing things like extending through JSON fields, but the query semantics became, well, indecipherable and disastrous. And ultimately, it didn't really have traversal. And even as graph APIs were grafted onto these tools, it didn't really fundamentally change the fact that the underlying architecture, data architecture, is wrong. And what you actually see on screen is our current product in sort of raw mode, displaying what the mess looks like when you start trying to build complex hierarchical directed graph plus bipartite type stuff using a relational database. You very quickly get a giant mess, and it leads to all kinds of issues, key reference abuse, and ultimately bad code. If you're using the wrong data model and data architecture, you're going to end up with code that reflects that, no matter how hard you try to make it good. So what we've built, frankly, could only have been done on top of Neo4j. Our schemas are well defined, but continually expanding. But we needed something that didn't force a base static schema model in the same way that, say, a traditional relational database model does in terms of architecture. We have this issue where our data is both directed, so we have to map things that have strict child parent-child relationships. But we also have to deal with a lot of referential relationships, a lot of things where, class derivation, things like that. And for us, and this is really key, edges are as important as nodes. So what we're able to understand and map around the relationship between entities is extremely important. And that means that the relationship itself has to be a first-class entity. And then I think the other thing is traversal was a big key for us in terms of being able to perform a lot of actions around fuzzy matching, identifying and delving into that data. And so what this all rolls up to is it allows us to go pretty deep in terms of what we're doing. And that includes binary artifact decomposition, runtime inspection, database and data model scanning, some of the things I've mentioned before. And it's important that when you're trying to gather this data, that it's as comprehensive as possible, because that's how we are able to deliver value around really understanding what the impact is going to be when a change occurs, when you introduce new things into the system, when you have to change things that are fundamental, et cetera. So where does this come into AI? Well, AI is great. And I actually think it is, in many cases, profoundly helpful in terms of jump-starting projects, in terms of moving things forward at a greater clip. But there are challenges with current generative AI. LLMs have a context problem. And I'm not talking about context length in the traditional sense. I mean broader context, as in trees versus forest, the ability to discern that changes that it's proposing or things that you're quickly working through and applying LLMs for to make changes lead to pretty significant impact challenges that may actually end up, well, in many cases, taking code that was good. And we've seen this ourselves in employing these tools, taking code that's actually good and having to back it out at the last minute because of the broader impact that that's having. And this is actually a measurable phenomenon, wherein we're really seeing some significant challenges around this. And in fact, this is something that's come up from a customer standpoint quite significantly. And so we thought it would be interesting to sort of delve into what we can do around that. So how do we address that from a dev standpoint? We're trying to provide context beyond what I call the open file. That could be the repo, it could be the project, could be the application boundary that you're working in, but other systems are dependent on that. They're interacting with that system. And what is that bigger picture in terms of the impact scope? How big is that blast radius? See before you commit is a big thing for us, because today, a lot of the time, what's happening is post-commit, you're well into test. Now you're already on a ship boundary. Before you know it, you're backing things out. And again, we're back to the point where you're spending a lot of time trying to remediate the impact issues versus getting on and dealing with more code remediation or producing new code. From a lead standpoint, alerting and highlighting other team members about what's going to happen. Know before the commit hits. And potentially give you information that allows you to provide the LLM with more salient prompts. And perhaps take into account things that you need to take into account that aren't immediately obvious. And then from an architect standpoint, it's planning changes rather than accepting. A lot of the time today, architect starts off designing this grandiose and beautiful thing, but at the end of the day, as that system evolves and they're supposed to be maintaining architecture and consistency, the reality is you end up having to accept changes because, going back to that original premise, planning is a real problem. So have conversations in advance. And as much as I think asking for forgiveness often is a good path to getting things done quickly, sometimes it is better to ask for permission. So with that having been said, I'm going to hand this over to Brandon, who's going to do a quick demo around what it is we do and how you can use our product in the context of generative AI. And with that, Brandon, I'll hand it over to you.
All right. All right. We're going to start in the IDE. So, we come into this, we're going to do a bit of refactoring. We're taking a look at a class, do some refactoring. There are some opportunities for improving this. And what we've done is actually asked GitHub Copilot, make some changes, do some improvements, and we're going to take a look at the output from that. And what we've got is, some improvements. Overall, the code looks a little bit better. There are nice code comments. As a reviewer, I'm probably going to come in here, see that in general, it looks a little bit better than it was before. There are now code comments where there weren't before, and I'm probably going to accept that, which is fine. Somebody's going to merge this in, and that's kind of where we're going to run into some trouble. Because if we take a look at CodeLogic and we go into change requests, we can actually see what the impact of this specific PR is to the other applications that we're concerned with and the other applications that we're working on. So within change requests, we kind of go beyond your typical red-green differential, where we only show you things that are impacted, and you can actually see the level of impact for each of those items. So we know we've made changes to company info library, and we have salary app that's showing up here. So we can actually take a look and see how salary app is being impacted. And we have a method that was actually calling add prefix, and now that's actually been removed. And we want to know, why these other applications are showing up. Well, get report actually serves up an endpoint. So it's been impacted, and it's impacting this endpoint that it's actually serving up as a REST API. So we can actually take a look at this guy and see that, report via API invokes get report to pull that down because it's a separate microservice, and it would actually also be impacted by this change. So, a simple change where we've removed this, done some refactoring. Now we've broken a couple of other services, and those would be kind of unexpected changes. Maybe it shows up in test. Again, maybe it's at a release boundary, and you have to handle it then. Do you make changes to these applications? Do you shelve it, and then somebody has to deal with like a merge conflict later? So how could we prevent this in advance? So if we take a look at search, in CodeLogic, we've actually scanned in all of our applications. We have company info library, we have our report via API, and if we take a look at salary app again, we can see that it's using add prefix. So we could actually do, during sprint planning, we could actually take a look at add prefix, do an impact analysis, and see, how, if I make any changes, what else is going to be impacted? And we could see that salary app, it's over here, it's consuming add prefix. Maybe I need to put a stub method in, mark it deprecated so that the salary app team knows about it. Maybe it's that communication up front so that, hey, we're making changes, just so you know about it. These changes are coming, and you would actually have that opportunity in advance. But maybe you don't do this during planning. Maybe this didn't occur. Well, as a developer, you live in your IDE day to day. And before you ask AI to make changes or make changes yourself, you go to add prefix, you do your typical find usages. And as far as the IDE is concerned, there are no other usages of this method. It, within the context of this particular project, it's not being used anywhere. But within CodeLogic, we can actually see that there's a method called getReport that is actually utilizing this. So if we make changes, what else are we going to impact? We can actually click on this. It's going to take us back to the IDE, and all right, back to the UI, and we can do our impact analysis. And so within within the UI, we can see that get report actually serves up an endpoint, and not only would we be impacted, but the report via API maintainers would also have impacts that they would need to account for. So that would be an opportunity, to either, again, put in a stub method, chat with these teams, let them know changes are coming. But maybe you find that, that team that creates the company info library isn't really good at communication or doesn't have the opportunity for it. What you can actually do is wrap that code with CodeLogic annotations. Drop your name in here, and you want to be a reviewer on the PR, or you want to be notified that changes are made. So what will happen is, if a change is made to the company info library, the PR is put up, you're going to get notifications in Slack so that, hey, I have a change that's coming. It's potentially going to impact me. I want to be aware of it, and I can actually see those and go out and take a look at that PR. It gives you that opportunity to have that conversation in advance, and as opposed to once that library change has landed. But maybe the planning wasn't done, the PR wasn't there, you didn't have the annotations in place, or it's a third-party library, some open source library that you're pulling in, and there's a new version out, and you want to know how that's going to impact you. So the other option that we have within CodeLogic is we have Release Assistant, which is kind of a what-if simulator. I'm going to take my application, I'm going to pull in that new library, and I want to see how that's going to impact me and the changes I need to be aware of. So as the maintainer of the salary app, I come in here, I pull in my new company info library, compare it to the old library, and I want to see what changes have been made. And I can see that, okay, I have add prefix that's been removed, add suffix has been removed, and I have this new method called add prefix and suffix. Great. Well, again, only things that are impacted are showing up. So my salary app is here, and I want to know how that actually impacts me. I can see that, yep, add prefix has been removed, and I have this new method called add prefix and suffix that I'm going to have to make changes to, consume this new method. But at least I know in advance, prior to, pulling in this new library, I can actually plan for those changes and actually have that opportunity to do it in advance versus finding out once I pull in the new library. And this is, it's kind of a small example and it's a very simple example, but it is something that we're seeing happen with customers on a very large scale. And for some of our larger customers, they have microservices where now it requires a meeting before you can actually make those changes, because you need to make sure that the changes you're making aren't going to break somebody else's microservices and changes, and have breaking changes there. So that's kind of it. I'll hand it back to you, Ned.
So yeah, so a couple of things. A good example of where we use this ourselves, because we dog food our own product, is we had an instance where we had to do a refactoring to address moving to Spring 6, and this is in preparation for our underlying database upgrade as well. So, which is Neo4j. And so in that context, where we were able to employ this was to actually get ahead of that and subsequently not let that become technical debt that lived forever in terms of that reliance. And that's not a small lift by any means. And so through a combination of, and to say we did this rapidly and with a single team member, which is, I think, pretty remarkable. I thought this was going to be a multi-month exercise, that we were able to get this done while we're working on other things, while we're still delivering, get that rework done and address all of the changes, address all the issues that came with a major version upgrade to a fundamental framework for us, I think was pretty remarkable. And it was done using a combination of enablement tools like generative AI, in combination with understanding upfront from a planning standpoint, quite literally running Spring through our release assistant and understanding, okay, this is all the stuff. I mean, here, this is a simple example, but we were able to get a comprehensive example of all of the potential impacts that we were going to be dealing with and focus accordingly and get that work done, which I think is pretty neat. The other big thing we didn't really touch on is the implications of being able to inform the test side of things as these changes are happening. So, for example, one of the big use cases that's come up for us recently is addressing the test side of things, wherein you've got functional tests. These are usually code in their own right that has to be maintained and so forth. And this in turn leads to a maintenance problem versus an actual problem detection issue. And what we found is by being able to inform tests upfront in a reliable fashion, hey, you're going to be impacted by these breaking changes, breaking for their tests. That saves a lot of time and a lot of, nasty grams and notes from tests saying, is it broken, or did you guys change the code, fundamentally? So it's been that's actually become one of the major use cases for our product. Brandon, I will take back the screen. First, before I go any further, Tobiah asks and hopefully, Tobiah asks, are we built on top using abstract syntax tree? Well, we use the correct way to put that is multiples, because depending on what we're looking at, for example, if we're decomposing stored procedures, server-side stored procedures, functions, and so forth, we use a different pattern for AST in that domain than we do, for example, when decomposing Java bytecode or .NET IL and so forth. Additionally, quick note on how we approach solving these problems. So we have agents that we have everything from things that plug into the repo side of things, the DevOps side of things around looking at source and or as built. And we tend towards looking at as built artifacts. And what I mean by that is it's the stuff that comes out the other side of the build system. So jars, DLLs, et cetera. And decomposing those, because those tend to represent a more accurate view of what the actual end state after it's gone through compile, build, and so forth. Because in reality, a lot of stuff is potentiality prior to that. And on the flip side of that is we also have agents that will profile the actual executing code. So we look at this stuff dynamically so that we can understand what's happening as that code is executing, because in many cases, you can only see certain things: dynamically generated connection objects, procedurally generated queries, things like that only become realized as dependencies when it's actually executed. And so all along the way, we're trying to get an accurate view of that. We often say source is not a source of truth because it's just potentiality. We actually try to get as far into that chain as we can. And that includes data tier, it includes queues, and includes all of that stuff because it all plays a role. So I just wanted to highlight that really quickly, going back to the presentation here. So where are we going in terms of additional AI work that we're going to be rolling out next year? The first is LLM integration. So actually having the ability to provide the model context based on our graph data, because a lot of what's happening today, you're dealing with a model that's been trained on a large data set, but it in turn is not acting in many cases against, or in most cases against, actual hard data as part of the process of checking and cross-checking what's actually being inferred in terms of output. So for example, it goes and it tells you, yeah, go ahead, I'll rework all of this stuff in terms of method names and renames, ends up renaming things and so forth, and that's fine. But what's the impact, and how can we surface that right then and there and potentially provide an additional set of prompts that that backfeeds into that for purposes of getting you a bigger picture answer to that. The other thing is, we want inference to be influenced by hard data, not just trained algorithms, meaning stuff at time is actual hard data, stuff that, as I say, looks more like an expert system. And then with that, we're going to be driving towards better decision making. So reliable automation of dev pipeline decisions, meaning the stuff that today you kind of have to sit there and say, okay, am I going to accept this or not? Can we help streamline that based on being able to tie in and look at what the impact is, reliably say, yep, no, this is relatively small impact, the risk is low, you can just click yes, and so forth, along with automated diagnostics. Actually, this is a big problem, and here's all of the reporting. And we actually already have a bunch of this reporting for manual use, but we want to wire that up in a more automated fashion. And then a big one for us is architectural prediction. What are you doing today in terms of pattern, architecture, and so forth that's going to lead to big problems down the road? We have a problem in this industry where we like to use patterns, and we like to use new shiny things to solve problems, when in many cases there are sort of fundamental issues that don't involve patterns. They just involve what's happening in the progression of a life cycle of a code base. And if we can upfront say, hey, you know what, these choices you're making right now are going to, based on inference and looking at where systems existed in their lifespan over time and how that graph evolved, because in our system we do store this stuff in ways that can be looked at over time. You can think of it sort of as graph snapshots and so forth that we are able to store and look at. Our goal is to start making architectural predictions around what's likely to happen based on changes in the here and now. So what's the upshot of all of this, and what we're driving towards is, we like to say, code fearlessly. Be able to do things without having to constantly be concerned about what the massive impacts are and so forth. And a big part of that is enabling people to plan effectively. Don't guess, know what the impact is. If you're asking the LLM to do something, and be able to then look at the output, profile it, and then gauge it against the existing system from an architectural and graph standpoint, allows you to say, all right, this is this amount of work. Maybe it's more work, maybe it's less. But the goal is know what the impact is, unblock major changes, and be able to do it while writing code, and end late deliverables, and so forth. And then with that in place, we can start working towards ending entropy. Well, perhaps not ending it, but at least fighting back against it more effectively. Not breaking things in flight, not fearing the Friday night deployment, tests not having to come back and hold everything up. And I think the impact is lessening the results around broken software, and then knowing what changed and what was impacted. Get to root cause, stop backing out good code, because there's a lot of that going on in the industry right now. Per that statement from VS Magazine. So with that having been said, I will stop it here, but open it up for any questions, if anyone has any.